Hello and welcome back to the lab. Today on the bench we have the scope calibration plugin set. For those who are just finding the channel and haven't looked at some of the previous videos, these three plugins, the PG506, the TG501A, and the SG503, are pretty much the base scope calibration plugins. These units can get you up to probably a 475A range without stressing too much. The real limitation there is the fast rise, fast fall inputs for doing the high frequency calibration on the vertical amplifiers, and then the SG505 or SG503 runs out of gas at about 250 megahertz. So can't really test it. Can't do a 485, but it can do a 475A. To do a 7000 series, this is enough to do most of the 7000 series vertical plugins. Obviously, speed being an issue. When you go faster, they'll need a little bit more exotic gear. Usually edge speeds again on the fast rise, fast fall. This can't do a frame by itself. These plugins are used a lot in doing the frame, but doing the actual frame itself, you need the calibration plugin for the frame. I have some more 7000 series scopes to go through, so we'll be digging those out in the near future and getting through there. This was sent in by a viewer of the channel. He ended up picking up these units, which are in amazing shape. These are, I don't know where he found these, but these are fantastic physically. The other thing is, this is about as recent, I think, as you'll find for these series of plugins. We have the A version of the PG506, the A version of the TG501, and there was no A version of the SG503, but this is new. This is the new front panel style. I'll get one of my older ones here. This is kind of what the older front panel looked like on an SG503. It also has a better display. Hopefully it's not using those custom digits, because those were problematic to find in some of the earlier restorations. If you're interested in those restorations, take a look at the channel history. I've done videos on a lot of these plugins already, but we're going to go through these. The other thing that's interesting that you don't see very often is we have a TM503B. I'm used to seeing the A's and the not even labeled, so the TM503 or 503B or a 503A. So we have a B version here. So that is cool. What I was asked to do is take a look at the plugins. The problem is you run into a chicken and the egg kind of issue. When you buy one of these, you want to validate the plugin, but you need better gear to validate the plugins than the plugin. But these are the standards of which you calibrate a scope with. So they're usually the best someone has in the lab. So how do you find better gear to calibrate these, to calibrate the calibrator? In the lab here, my basis of time is a Stanford Research 725. That is a rubidium frequency standard with exceptional phase noise and stability, which is also backed up by a GPSDO. I have a couple of videos on that system as well. So it is a 10 megahertz reference that is locked to the cesium at NIST through the GPS network and is unchanging, unaging. I don't even need to calibrate it. It self-calibrates. I do have a readout on the computer on what its error is currently. It's actually running 0 nanoseconds. So it is 100% in sync, locked to the 1 pulse per second coming out of the GPS. So I don't know if it just servoed, but it usually stays within about, the pulse edges stay within about 9 nanoseconds of each other at the worst. So 0's dead on. PG506 has an exceptional DC accuracy. If I remember the specification right, it's plus minus 0.025% is what I want to say. So you need a meter better than 0.25% to check it. Well, it has the same DC accuracy as my 6500 right there. So I can't use that to check it, because if it's off, is this off or is the 6500 off? And then you can get into tolerance stacking where this is off at its extreme end, the 6500 is off at the other extreme end. Now you have a wide gap but that gets into measurement uncertainty and a few other things. So to align this, no, the 412A is the same as this, but I do have which is moved. It used to be up here. It's now down there. 7510, 7.5 digit multimeter in the lab for resistance, volts, using that as a standard. And then for current, I have the 7510 for checking current supplies, but then I also have a 2450 that I can use to source and sync current to check current standards or supply current for a meter for calibration. So the time mark generator is actually the easiest one to align. You pop the front end into a frequency counter and validate it. So frequency counter backed up by the rubidium. Hit this, check it. I did have to do an extensive rebuild on one of these. It was one of the older units, and go from there. And then the leveled sine wave generator, getting into calibrating that, which we will also validate and take a look at, because I've been asked to rebuild all these units and get them ready for the long haul. The SG503, checking its leveled output is a little weird, and the SG503 is even more weird because, one, this dial does not go to 0, it stops at 0.5, because that's the lowest output this will do, is 50 millivolts. Or no, 5 millivolts? 5 millivolts, maybe. And then it'll go up to 5.5 volts at the high end. You have 3 decades here. And then we have a dial of voltage with a 10-turn pot. But if you read here, it says calibrated with cable, and it gives you a part number of the cable. It's a very accurate 50 ohm cable, and it's not hard to find. And when you do find it, it tends to be on the more expensive side. I have one. I don't use it with mine very often for doing calibrations because the error that it puts into the system is not high. So you can use an SG503 without the cable. When using an SG503, if you're doing relative measurements, not exact measurements, and you don't necessarily care what the dial setting is here, you can get away without having the super precise cable. It's only when you need to dial in and this needs to match what's coming out of the end of the cable that you need the calibrated cable. That is not true for the SG504, which goes up to a gig 40, 1040 megahertz. The leveling head that's in that unit, you must use the leveling head. If you don't have the leveling head, it won't work. The SG503 will work, the SG504 won't. That's a little bit between the two. The SG504s are starting to get very rare and very hard to find, and the leveling heads are getting even harder to find. So if you don't need it, stick with a 503. It will be less expensive. Check-in wise, first thing we're going to do is we're going to start up this frame. Now, this is a newer frame, so what I'm going to do is I'm going to pull all the plugins out, plug the frame in, power it up, make sure it doesn't short out the power supply. Then I'm going to plug a power supply plug-in and just check all the bays. The important part is there's pass elements for each bay that are in the frame itself. So essentially the frame is just a power supply and a couple of high current transistors. Those high current transistors in some of the frames do tend to blow. When they do blow, they can take plugins out because one of the main reasons, they're they do different things depending on the plug-in. One of the main things they do is pass elements for the voltage regulators of the plug-ins. So when those are shorted, it's not a good day. So let's power up the frame, and then we'll just sanity check the plug-ins, make sure they're doing what they're supposed to be doing, and at least giving us some sane output, and then we'll check deeper. Okay, we have the power frame on, and our goal here is no smoke. So right now there's 0 volts coming in from the isolated supply, and I have the current limit set to 1 amp, but we don't have any plugins, so that's fine. There's 60 volts. We're drawing about 800 milliwatts. Bulbs are not lighting up at all, so we're getting good indications there. There's 101, just over 2 watts, so we'll just go up to 120. And we didn't even move the needle on the load meter. We're drawing about 3 watts at 100 and we'll call it 120. And my bulbs aren't even lit, so this power frame is A-okay. Let's get a plug-in. Now I have the power frame off when I'm installing the plug-in. This is a PS503A. I haven't even rebuilt this plug-in yet. This is kind of my test plug-in for power frames. And it looks like we are good. This is not a high power port because it's not a 4-bay frame. So this is stuck to 40 milliamps max, which is normal. The output will on. Let's see if we're actually getting power out. We'll just start up a meter here real quick. Zoop. And we're getting output. Everything is looking good. Turn up both supplies, and I can get a full 20 volts out of the power supply. So that is working as expected. Let's move it to the next bay. This has some pretty big caps in it, so it will take some time to power down. That's normal. They do make a frame test plug-in for these units. I do have my eye out for one, and NFM, the channel Near Far Media, he has a test plug-in. Essentially, all the test plug-in is resistors and some LEDs and things like that to check the ripple on the power supplies and properly load down the units. I'm not sure if that works for the six bay frames. I don't know if it'll fully load the power supply because that's a lot of current draw. But 20.22, this one's fine too. Even I don't think the Tech one does the full load of the power supply. So, yep, 20.22. And just to check, we should get negative 20.23, negative. Yeah, everything's looking fine. So the bays are good. So now we can power up the plugins without fear of blowing up the plugins and give them a quick check. Okay, we have all the plugins back in. And I have a scope turned on, so we can start kind of sanity checking some waveforms. This will not be a deep dive into each one of these plugins, as for as simple as they are, there is a surprising amount of stuff to validate one of these. And you need a surprising amount of gear. This is one of the reasons why this port right here, because on the time mark generator, it can go up to 1 nanosecond per division, which is a 1 gigahertz signal. So that is quite quick. Way too fast for my 7603. Set this left. I'm going to push this back. We'll get the 7603 in the shot so everybody can see what is also going on. We're going to set this to standard amplitude. Going to set this to 20 millivolts per division. We're on 10, so we should see 2 divisions of square wave if everything works as expected. Let's see. Okay, well, we have good... hey, look. We'll get this triggering here real quick. AC, high frequency reject. Slow this way down. Well, that's a problem. The deflection, or the error should be reading. So we have an error on the PG506. Well, that's not good. Something to troubleshoot. So we have our first fault. Let's see if high amplitude's working. Okay, that's weird. These plugins should not talk to each other. I switched this to high amplitude with it set to minimum, and the frequency goes nuts on the SG503. So that's strange, to say the least. Okay, I can adjust amplitude. And I can adjust frequency. So that's working. So now the question is, do I have a frame problem or do I have a plug-in problem? Let me get my test unit and we'll pop the PG506 into my test unit and see if it behaves. Try to get this all in the shot here. We have the PG506 tucked into my test frame. I'm going to kick this on. And, well, we're at standard amplitude and 50 millivolts, and now we have 5 divisions of display. So this is looking a lot better. So, power problem, because I still had it on the current limit, or frame problem. Let's plug this back into the frame and bypass the current limiter, and then see if it behaves. Okay, we're back in the 503B with PG506. We'll fire this up again. That looks better. We're also drawing 47 watts. And now my... All right, let's turn the current limit back on. Yeah, so the voltage is falling out of regulation. It is drawing, with the plugins installed, it's drawing too much current, and it's falling down to 93 amps, so it's falling out of regulation. So that is what is causing the problems with the plugins. This is a linear supply, so that didn't hurt anything, but using the isolation transformer and variac supply on switch mode power supplies can blow stuff up. So, with that being said, this looks good. Let's check our high amplitude now. Kick down here. We'll go to 5 volts a division. We'll dial up the amplitude so you guys can see it. Yep, that's going to be a problem. Here we go. Got some capacitive coupling. I got to rock the switch back and forth on the scope. The contacts are a little dirty on that one. But our high amplitude, and it actually looks better too. It was falling off a little bit, so that looks a lot healthier. Let's check some timing pulses. I'll need a 50 ohm. Timing pulses need to be terminated into 50 ohms. Actually, let's check fast rise too while we're here. Fast rise outputs. This is middle is rise. This is labeled backwards. It's actually really confusing. Which one's rise and which one's fall. There it goes. Yeah, so this is looking real good. Here's our fast rise and nice and flat, so I can give it some more signal. Yeah, we have lots of control, lots of signal. So our fast rise output's working. How about fast fall? Fast fall is also working. Now fast fall, the wave shape is we're coming here, and then this is the portion of the wave shape that's of interest, is the falling edge, not the rising edge. So we see we have a bunch of overshoot and everything here. This is okay. This is normal because we're interested in this edge, whereas on the fast rise edge, we're interested in this edge. That's the difference between the two. Since we got the 50 ohm terminator, let's do time marks. Marker output. And back this off just a touch. Trigger. We're on 0.1. Okay. Interesting. So, why can I not trigger this? What's going on? All right, let me get an external trigger. That's kind of interesting. That's not a failing of the plugin. That's actually a failing of the scope. It doesn't want to trigger internally. Have I bumped a button? Auto AC internal. Nope. All right, we're going to do external trigger. And right there, now we should be able to trigger. So why has my plugin just stopped triggering? Okay, let's grab a different time base. Have a couple of more of these done up and fixed. This one may need a little bit of help. Let's try reseating this real quick. Oh, that was the problem. I misread it. Now it's triggering internally. It was running too slow. There we go. More familiar waveforms. Okay, I was telling the scope to sweep at 0.1 milliseconds, and I had the time mark generator set at 0.1 seconds, so it was just running, the trigger was just out to lunch because it was running way too slowly. As we can see, we get nice time marks. We can check the frequency real quick. Since we're here, we're just spot checking stuff. I am going to do a full calibration on these for their owner. Wow, but that is really close. And that's with the frequency counter not warmed up. I just turned it on. So we'll go to time and period 1. And my period is 100 microseconds, 0.1 millisecond. Yeah, 50 micro, 20 micro, 10 micro. And this is without the frequency counter warmed up. 5. So the time mark generator is working well and is actually very accurate. The other one we'll check is, we'll just sanity check some sine waves. Wasn't sweeping. All right, so kick this over to DC. Give me some signal. That looks good. Nice amount of signal. So we got nice looking sine waves. Coming out of the SG503, I can vary the amplitude, can vary the frequency without too much trouble. The ranges seem to be working. Yep, they're looking good. So, to be perfectly honest, these plugins look like they're in great shape. So, we will do some capacitor replacement. Well, I'm going to talk to their owner, figure out how far he would like me to take it, and then we'll go from there. But other than checking them, I mean, at this point, depending on what the owner's preference is, they could be checked and calibrated, see if they meet spec. If they meet spec, you can run with it. We could do a light recapping on them. We could do a heavy recapping on them, get them ready for the long run. Some of the controls were stiff, so I do need to service some of the switches and the controls. I wish YouTube was Feel-O-Vision, because a control that's properly serviced and not binding feels a lot different than a control that's sticking. So it's very easy to... you can just feel when the control's crunchy and when it's actually working right. But these are all in good shape, so immaculate condition. I do wish these were mine, but they're not. So I will find out what their owner would like to do, and then we'll go from there. But these are in really good shape. I'm actually kind of impressed. Even the power frame's not in bad condition. So everything looks good. As always, if anybody has any questions or comments, I read all the comments in the description and look forward to talking to everyone between videos. If there's anything you'd like to see on the videos, I have gotten requests for more 7500 series content. So here we are, and here is what we'll be doing for a little bit, getting some more stuff up and running and saving it from the landfill. With that, if you're finding you're enjoying the videos, please hit the subscribe button and check all the bells. As always, more is on the way, and I will see everyone in the next video.